So to solve this problem, we need to start from the definition of the Fourier transform, which is given in the question. We can see that the Fourier transform f of k is given by 1 divided by the square root of 2 pi. Then it's the integral between minus infinity to plus infinity, the function we wish to take the Fourier transform of, and then e to the minus I kx integrated with respect to x. Now we can make the problem a little simpler by noticing that this is an even function. Because it's an even function, we can use the cosine approach, which makes the maths a little bit easier. So we can write in this case that the integral is 1 divided by the square root of 2 pi, and then it's the integral between minus infinity plus infinity f of x and then cos kx dx. Now we need to put the function in, and we notice that it's an unusual function in the fact that it cuts off below minus alpha and above plus alpha. But as we've seen in the lectures, we can deal with this by changing the limits to the integral. So we can write that f of k is equal to 1 divided by the square root of 2 pi, and then the function is only non-zero between minus alpha and plus alpha, and there it has a value of a, and then we have cos kx dx. The final step we can take is to notice that again we're integrating an even function, and so instead of integrating between minus alpha and plus alpha, we can simply integrate between 0 and alpha, but then we need to put an extra factor of 2 into the integral. So finally we can write that the Fourier transform is given by 2 divided by the square root of 2 pi, and then the integral between 0 and alpha, a cos kx dx. We can now take the integral. We get 2 divided by the square root of 2 pi. The a comes out because it's a constant, and then we've got the integral of cos kx. That integrates up to sine kx, and there's a factor of k comes out, which goes into the denominator. When we evaluate the function, we can see that the upper limit is going to give us sine k alpha over k. The lower limit is just going to give us 0, so only the upper limit contributes. So we get 2a divided by the square root of 2 pi sine k alpha over k. And then the final step is to note that what we have in the result is something that looks a bit like a sinc function. We'd like to make this a sinc function of k alpha, so we need to multiply top and bottom by alpha. So finally we get that the Fourier transform is equal to 2a alpha divided by the square root of 2 pi, and then it's sine of k alpha divided by k alpha.